this clip, you're going to learn and understand why we usually have chlorine surrounded by this configuration. Then you see something like this, hydrogen. How do we come about these electrons over here? That's the essence of this video. Or for example, again, where you have nitrogen surrounded by something like this, how do we come about this non-bonding pair here? Right, this lone pair of electron. So that's what this video is focused on. So firstly, we would look at oxygen. Oxygen is part of what we'll be looking at. So let's look at oxygen, for example. Now oxygen is, atomic number of oxygen is 8. So we're going to have 1s2, 2s2, 2p4. All right, so what does this mean? It means that oxygen in its shell configuration, all right, the one S2 is going to have, in the K shell, is going to be 2. Then we have 6. This 6 can go into the next shell, which is, whose maximum is 8. So I'm going to have 6, right? 1, 2, 3, 4, 5, 6. So if you look closely, in the valence shell we have 6 electrons there. So what this means is that oxygen is always surrounded by 6 electrons. 1, 2, 3, 4, 5, 6. So that is how we come about these electrons residing on the atom when we are writing reaction mechanisms. Okay, so with that being said, if you look at the compound CO2, or you look at the compound such as the carbonyl group, how do you represent this correctly? Now oxygen is surrounded by 6, right? So I'm going to have 1, 2, 3, 4, 5, 6. And if it's going to make a bond with carbon, how do we do that? Carbon is 6, atomic number is 6, so we have 1s2, 2s2, 2p2, right, making it 6. So this is the K shell, and we have 4 here, meaning that this 4 can stay in the outermost shell, right? So it means that carbon is always surrounded by 4 electrons. Can you see that? So in this case, I'm going to put the 4th one here. Can you see that? So when I've just introduced it here, it means that this can form a bond. Can you see? And if this happens, I'm going to have carbon here. You can see here we have this one and this one. These are non-bonding pairs, 2 non-bonding pairs of electron. So if I'm to write this correctly, it's going to be carbon, oxygen, and this. Usually we don't get to show these ones, but it's also there, right? So that is that. Now if you look closely to oxygen again, remember oxygen is always surrounded by 6. So I have 1, 2, 3, 4, 5, 6. So if it's going to bond with an atom, say hydrogen, you know that hydrogen can only give 1 electron, right? So, and if that happens, it's going to form a bond. So essentially we're going to have this, and this residing. So if that happens, I'm going to have oxygen forming a bond with hydrogen, all right, with how many? 1, 2, 3, and 4, right? So those 4, I'm going to include them here. 1, 2, 3, 4 in form of pairs, and that is how essentially we come about these ones. Can you see? Just based on valency. So we can say that the water molecule, regarding to when you're looking at oxygen, it's having two lone pairs of electron, two of them. This is one lone pair, this is another lone pair. They are pairs because they are two, right? So that is it. And then you have the bonding pairs with hydrogen, this and this, right? So that's basically it. And you should be able to also note in terms of nitrogen. Let me use this as a final example. Nitrogen is 7, so we have 1s2, 2s2, 2p3, right? So that tells you that 1s2 can go into the K shell. Here if you add it is 5, so the maximum in the atmosphere is usually 8. So that means nitrogen is always surrounded by 2 plus 3, which is 5. So I'm going to have 1, 2, 3, 4, 5. And if this wants to go into reaction with hydrogen, hydrogen can only give 1, right? Hydrogen can give 1, and hydrogen can give 1. That will lead to the formation of ammonia. Can you see that? And that is why we always get to see nitrogen having this non-bonding electron, this one lone pair of electron. So if you have nitrogen, this is ammonia, right? Ammonia, you always see that it has been represented with this non-bonding electron. And as you can see, we've just accounted, so you understand why we always have the non-bonding electrons residing in atoms. All right, so this is basically how we come about all these things.